for example number 5, we want to determine the slope of the tangent line to the graph of this function at the point 3, 1. I forgot to write the tangent line, but you get the idea. So this is kind of a funky function. I graphed it over on Desmos, so you can take a look at it. It's kind of cool looking. It's like figure 8. And then here's our point 3, 1. So we want to determine the slope of the tangent line right there, which looks like it's going to be a little more than 1. Hard to say. So absolutely for this, we do not want to solve this for y. I'm not even sure that we could. We are going to use implicit differentiation. So we are going to take the derivative of this entire thing with respect to x. Okay, let's start on the left-hand side. The left-hand side is absolutely a chain rule. So we're going to bring the 2 down. So 3 times 2 is 6. Then we have x squared plus y squared. We lower the exponent, so to the first power. Then we need to multiply by the derivative of what's inside. So the derivative of that, derivative of x squared is 2x, plus the derivative of y is 2y dy dx. That's the derivative of the left-hand side. All right, the right-hand side. This is a product rule. Okay, we have 100x and y. Okay, those are our 2 pieces. So product rule is 1d2 plus 2d1. So here's 1 d2, the derivative of y is dy dx. So there's 1 d2 plus 2, that's just y, d1. The derivative of 100x is 100. Kind of got that squeezed in there, okay? So that's our derivative. Yay. Let's see, what are we going to do with this? I think we need to get all the dy dx's together. So this is kind of a unique thing. What I'm going to do is I'm going to take this whole thing and distribute it here and here, okay? So that's going to give us 12x squared plus y squared plus 12y dy dx x squared plus y squared. Now, you could distribute and like separate out that x squared plus y squared, but we don't need to. Okay, so I'm going to leave it this way. Other side is just 100x dy dx plus 100y. All right, our goal is to get the terms with the dy dx on one side and the terms without the dy dx on the other side. Notice I have 2 terms with the dy dx, one on the left, one on the right. So I'm going to move the dy dx's to the left side. So this one is staying put. So 12y dy dx x squared plus y squared. And then this one is coming to the left, minus 100x dy dx. Okay, on the other side, this one's staying put, 100y. This term's coming over to join it, minus 12x x squared plus y squared. Okay, now on the left-hand side, we can factor out the dy dx, which leaves us with 12y x squared plus y squared minus 100x. And over here equals 100y minus 12x x squared plus y squared. Okay, I am really close to being done. All I have to do is, the dy dx is factored out, so I just need to divide both sides by that big thing, leaving the dy dx where it is. So that will give me dy dx equals this part, 100y minus 12x x squared y plus y squared over, and remember we're dividing both sides by this. I'm going to switch that around just so it looks different, pretty. negative 100x plus 12y, x squared plus y squared. I did not have to do that, but I just kind of like the symmetry, switching them around. Makes me happy. So we have our derivative. This is our derivative formula. Yay! We wanted to evaluate at the point, I'm thinking it was 3, 1. Let's check. Yep, 3, 1. Okay. So we are going to plug in 3, 1. Okay. We need more space, but yay, end of day 2 once we're done with this problem. So let's see if we can get more page here. So our slope, dy dx, is going to be 100 times 1 minus 12 times 3 times 3 squared plus 1 squared over negative 100 times 3 minus 12 times 1, 3 squared plus 1 squared. Okay, let's go this direction. So we have 100 minus, I don't know, I might use a calculator for that. 12 times 3 times, that's going to be 10. I guess I didn't need a calculator for that. 360. Over here we have negative 300 minus 12 times 1 times 10, 120. So that's negative 260 over negative 420, which is going to be positive, of course. I'm going to drop those zeros. I don't know, what is 26/49 reduced to? Kind of feel like that's not right for some reason. Yeah, we'll get to that. That's going to be 13/21. That's definitely not right. Plus sign. I see it. You see this? That was a plus, and I did it wrong. Okay, let's try again. It's not 21. It is negative 300 plus 120. Glad we found that. That's negative 180, which again, that made that positive. Drop the 0. 13/9. Remember I said from the graph it looked like it was bigger than 1, and the first time I got something that was less than 1. So, pretty sure 13/9 is our slope. Let's check it, because remember we could write the whole equation. If you were asked to write the equation of the line, you would do y minus 1, remember it's got to go through that point, equals our slope, 13/9. That's what the question was really asking for, was the slope, x minus 3. Okay, let's pop over to Desmos. I actually did this already. Here it is. That's that line. And sure enough, it is tangent there. Okay, so our slope is 13/9. So these implicit differentiation problems, they're a lot of work, but they're way easier than trying to solve for y and differentiate that way. So that is 3.5b. We will pick up and finish out the lesson tomorrow.